Number 46. A cioppino recipe calls for 20 medium shrimp and feeds 6 people. How many large shrimp are needed to feed 500 people? There's 45 medium shrimp in a pound and 33 large shrimp in a pound. Each person gets a constant mass of shrimp. So for these kinds of scaling problems, what I like to look at is, well, first of all, what are they asking for? They're asking for how many shrimp. So when I see that, the first thing I'm going to look at is how many shrimp do we need originally? So originally we needed 20 shrimp. And then look at what's changing. So first thing is changing is the number of people. We go from 6 people to 500 people. So we go from 6 people to 500 people. And then we're also going from medium shrimp, which feeds it's 45 medium in a pound, to large, which is 33 in a pound. So we're going from medium to large. So we're going to use some conversion factors to try to think about what's going to happen to the number of shrimp whenever these things change. So if we started with 20 medium shrimp, then we have to go from 6 people to 500 people. Well, in that case, we can just multiply by 500 over 6, because it's 500 over 6 times as many people that need being fed, so naturally there's going to be that many times the 20 shrimp. Now, for the medium and large shrimp situation, so there's two possibilities, and here's how you can think about it. One, you could multiply by 45 over 33, or you could multiply by 33 over 45. And reading this question, it might not be obvious right away which one of these you want to do. But you just think about the scenario. So if you're going to give people large shrimp, you're going to need fewer of them because there's 33 of those in a pound versus 45 in a pound. So if they're larger, you need fewer of them to feed the same amount of people. So you're going to multiply by the conversion factor that will reduce the amount. So I'm going to multiply by 33 over 45. So I'm going to get out my calculator. We're going to do 20 times 500 over 6 times 33 over 45. And we end up with 1,222 shrimp. And it says integer, so we don't do 3 significant digits. 1,222. All right, let's look at number 47 next. Let's see, what is the regression coefficient for the data 1, 43, 2, 99, 3, 150, 4, 180, and 5, 122? So this is pretty straightforward. On the Inspire, what you can do is go to Menu, 6, Stat Calculations, and then Linear Regression, either 3 or 4, doesn't matter. And then you just type in your X list and Y list. So for our X list, this has to be in the curly braces, by the way, curly brackets. Our X list just looks like 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then our Y list, basically do the same thing, just with the Y's. So 43, 99, 150. And then, what are the other two? 180, 122. So I have this. I'm just going to click Enter. All right, you can click OK. And you get this information. So this A and B actually tells you your regression line, but it's not asking for the regression line, I don't believe. Yes, it's asking for the regression coefficient. And the regression coefficient is just R. And so it looks like we're going to have 0.725 as our answer. So that's about as easy as those kinds of questions get. And then finally, for number 48, this is just a straight solver question. What is x if x is greater than 1 and 2 to the x equals 10x? So, once again, just go to your menu 3, 1. So 2 to the x equals 10x, comma x. Then I can do Control Enter. And we get 2 solutions, but it said x has to be greater than 1. So looks like our answer for this one is going to be 5.88. 5.88. By the way, this number 48, this is always a solver problem. And so if you're getting to this point in your test, you should never be skipping these because these are always just straight plug in your calculator, or just a simple graphing one where you just find the intersection point. These ones are always super easy. They're free 5 points. Well, anyway, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.